Welcome to question number 33 from the August 2017 Geometry Regents exam. This question's pretty lengthy, but it's involving a proof. So usually a good way to start is to create a table like I've done here with the statement and reason columns. And we're going to start off with the information that is given to us. The information we know is that we've got a circle labeled O. We have a tangent line EC. And it is tangent to the diameter AC. We have a chord BC that is parallel to the secant line ADE, and we've also got a chord AB. And the reason for all that is given. The next thing we can mention is that angle B is a right angle, a 90-degree angle. And we know that because any angle that's inscribed in a semicircle will always be 90 degrees. You may have also heard that as the semicircle property. Oh, now, by the way, the proof that we're trying to get to, that the ratio of the line BC to CA is equal to the ratio of AB to EC, the strategy we're trying to get to here is to prove that these two triangles, ABC and ACE, are similar. And by doing that, if we can prove that these two triangles are similar, we can say that the corresponding sides of similar triangles are proportional. That's the whole thing about similar triangles. So now that we've proven angle B is a right angle, the next step we want to try is prove that this angle here is 90 degrees. Now, because that we were told the line EC is a tangent to the diameter AC, we can also conclude that EC and OC are perpendicular lines. And this is because a radius drawn to a point of tangency is always going to be perpendicular to that tangent line. You may have also heard of this as the tangent radius property. So now that we've explained that those two lines are forming a perpendicular angle, we can conclude that angle ECA is a right angle. And the reason for that's pretty straightforward. I mean, perpendicular lines form right angles. So what we've just shown is that these two angles here that we've been focusing on are congruent. So that would be the next thing to say. And I mean, the reasoning for that's pretty straightforward. All right angles are always going to be congruent. They're all the same. Now we're going to switch focus to something else. We're going to switch to two other angles in these two triangles. And what we want to do is show that this angle here is congruent to this angle here, that they're equal to each other. And that's actually pretty doable because we do know that chord BC is parallel to that secant line. So we know this and this are parallel. And from knowing how alternate interior angles work, we know that they are going to be equal to each other. So you can see the statement and reasoning here. I'm saying that angle BCA is congruent or equal to angle CAE, and that's because the transversal of parallel lines will always create congruent alternate interior angles. Okay, so now we've reached a really good point. We know that these two angles are equal, and we know that these new two angles are equal, so we can conclude that these are similar triangles based on the angle. So now we've done it. We've gotten to the point we were trying to get to. We've proven that these two triangles are similar. Therefore, these two ratios are equivalent because corresponding sides of similar triangles are always going to be proportional. So you can see I've written down there the final statement and the final reasoning. So yeah, it's a pretty involved question, but I hope that this video helped out and it made sense to you. All right, thanks for visiting JD's Regents Preparation.